professor at New LJ Institute of Engineering and Technology. In last video lecture, we have seen the concept of indeterminate form. We have seen total 7 indeterminate form in last lecture, and we have also seen L'Hospital rule for two indeterminate form, that is 0 by 0 and infinity by infinity. But total 7 indeterminate forms are there. So today we'll discuss about indeterminate form, that is infinity minus infinity, and how to solve it using L'Hospital rule. So for example, suppose we are having two function, that is limit x tends to a fx equal to infinity and limit x tends to a gx, that is also infinity. Now if limit x tends to a, if we'll do fx minus gx, the form is like this. So it will give us an indeterminate form, that is infinity minus infinity. So how we are going to convert it into 0 by 0 or infinity by infinity? Then we can apply a L'Hospital rule. So if this form is having, so we can convert it into the 0 by 0 form using this. So this can be rewritten as limit x tends to a 1 upon gx minus 1 upon fx divided by 1 upon fx into gx. So this fx minus gx, that gives you infinity minus infinity. If we'll rewrite it using this form, then it is supposed to be converted into which form? 0 by 0. So basically we are having infinity minus infinity indeterminate form, then we have converted into 0 by 0. Now to this form we can apply a L'Hospital rule, right? Two step. First, infinity minus infinity is that you have to convert it into 0 by 0. Then same as the previous lecture, we have to apply which rule? L'Hospital rule, right? So we'll see it with one example. Suppose this is the example, limit x tends to 1 x upon x minus 1 minus 1 upon log x, right? So first try to put x equal to 1 into this equation. Suppose this is our fx and this is our gx. So x equal to 1. So 1 upon 1 minus 1. So 1 upon 0. So that will become what? Infinity. Minus 1 upon log 1. Log 1 is 0. So again we will get what? Infinity. So the form of indeterminate is infinity minus infinity. Now we'll try to convert it into 0 by 0 form. So we can rewrite it with what? Limit x tends to 1. This is fx, this is gx. So 1 upon gx. So 1 upon gx is itself 1 upon log x. Now minus 1 upon fx. 1 upon fx is x upon x minus 1 the whole upon 1 upon fx into gx. Fx is x upon x minus 1 into gx 1 upon log x. Just we will rewrite it again. So it will become limit x tends to 1 upon 1 upon log x, right? So it will become what? Log x minus x minus 1 upon x. Again this we have multiplied here, right? So it will become x log x and the whole divide by x. Now for this 1 upon fx into gx. So that can be rewritten as x minus 1 into log x upon x. So again this x can be cancelled out. So we'll be having the form of what? This thing. Right? Now if you put x equal to 1 into this equation, so it will give you what? A 0 by 0 form. So now we can apply a L'Hospital rule. So limit x tends to 1, here x into log x. We can say two different functions are there and we need to write what? The differentiation of that. So x as it is into differentiation of log x, that is 1 upon x, plus log x as it is differentiation of x, that is 1, minus differentiation of x, that is 1, minus constant, so it's 0, upon x minus 1 dot log x. Again multiplication, so we'll apply that rule. X minus 1 as it is log x, that is 1 upon x, plus log x as it is, right? X minus 1, the differentiation of that is 1. So we are having this form. Again we'll try to simplify it. So this x can be cancelled out, right? So it will become what? 1 plus log x minus 1. So it will become what? Log x. So here limit x tends to 1 log x upon. This also can be multiplied with this thing, right? So x into 1 by x minus 1 upon x. So it will become what? 1 minus, right? This x multiply with that, so it will give you 1 minus 1 upon x plus log x. Again put the value of x equal to 1 into this equation. So log 1, that is 0. Now this 1 minus 1 upon 1, that is 1. So 1 minus 1, that is 0. Log 1, that is again 0. So we will be having which form? 0 by 0 form, right? So again we can apply a L'Hospital rule. So equal to limit x tends to 1 log x, that is 1 by x upon. This one become a 0, the differentiation of constant is 0, minus 1 upon x, the differentiation of 1 upon x. So that can be 1 upon x, that means what? It can be x raised to minus 1. 1 upon x equal to, we can consider it as a what? X raised to minus 1. So according to that, we have to write down the differentiation. So for that, the differentiation is what? We have to write it 1 upon x square, and that minus, that will become a plus, right? Plus log x, differentiation of log x, that is 1 upon x. Now again put the value of x equal to 1 into this equation. So we'll be having what? 1 upon 1 upon x square, x equal to 1. So it will become 1 plus 1 upon x, 1 upon 1. So that is also 1. So we'll be having what? 1 by 2. So now this is what? Determinate value, right? So we can say that if we are having the form of infinity minus infinity, so that can be converted into which form? 0 by 0. Then we can apply a L'Hospital rule until we'll be having some value. So in that way we can solve the indeterminate form, that is infinity minus infinity. Now the indeterminate form, that is 0 into infinity. So for example, if limit x tends to a fx equal to 0 and limit x tends to a gx equal to infinity. So what happens? Limit x tends to a fx into gx, that will become a 0 into infinity form. So again, as infinity minus infinity, we'll convert it into what? Either 0 by 0 or infinity by infinity form. So it can be rewritten as limit x tends to a fx upon limit x tends to a 1 upon gx, right? That means fx, that is itself 0, 1 upon gx, 1 upon infinity. So it will become a which form? 0 by 0. And then we can apply a L'Hospital rule. So we can solve that example. Now for this form 0 into infinity, we will see one example. So example, limit x tends to pi by 4, 1 minus 10x into sec 2x. So we can consider it as a what? This can be our fx, this is our g, right? So it will give you which form? 0 into infinity form. So what we'll do? We'll try to convert it into a form of 0 by 0 by rewriting it what? Limit x tends to pi by 4, fx as it is, that is 1 minus 10x. Now upon gx. So here we are writing 1 upon gx, right? 1 upon, that is sec 2x. So that will become what? Cos 2x. So directly we are writing cos 2x. Okay. Now if we will put a pi by 4 here, right? So it will become in which form? 0 by 0. So we can apply a L'Hospital rule. So we can write it L equal to limit x tends to pi by 4, 1 minus 10x. So for 1 the differentiation is 0, minus sign as it is. For 10x it will be what? Sec square x upon. For cos 2x, that will be sine 2x but minus. So minus sine 2x. Again, here it is what? 2x. So we have to do the differentiation of 2x also. So the differentiation of 2x, that is x. Sorry, 2. So that will be here. So minus 2 sine 2x. Again, what we are going to do? This minus is supposed to be cancel out, right? So limit x tends to pi by 4. Will do what? X equal to pi by 4 in this equation. So we'll be having sec square pi by 4. Here sine 2x. So 2 into pi by 4. So that will become pi by 2. So sine pi by 2. So the answer of that, right, that will be 1. So if you are having the form 0 into infinity, that will be converted into 0 by 0 form using this fx and here 1 upon gx. And you can apply the L'Hospital rule. So you will get a answer. So this is about with infinity minus infinity and 0 into infinity form.